And how many of you use unit test module in Python? How many of you use py.test? Hypothesis? Coverage? Okay. Now I know where you're at. Fantastic. I'm going to hide behind this in case I get scared. All right. Okay, it's a rather high lectern, but I'm going to need it up here in a minute because I'm going to do some live coding for you. I'd hope to, for the beginners in the room, start you out with some of the basics of testing. There isn't much you need to know in order to get started with testing, but I'd like to very rapidly move past the basics and just show you how it's used in practice and how it's used at scale, and show you the things that I use to test the core of Python itself. I believe that py.test is probably the best test module around, but the Python core uses unit tests. So I'll alternate. I'll use some of each in the demonstration here. The testing tool doesn't matter as much. The focus of this talk is on how you write your test, not the tool that you use to run it. For me, that is actually the least interesting part. So here we go. I'm supposed to do my own introduction. So hello, my name is Raymond Hettinger. This is PyCon Italia. It's 2022. This is my first conference in almost 3 years. It is a delight to be here. 12 years ago, I went to PyCon Italia on my honeymoon. We got married, we came to a conference, and then we went to Morocco. We got here, and so this is a very cherished conference for us. And this time when we came back, we brought a 10-year-old son with us, who's an aspiring Python programmer himself. So you'll see the little guy around with me. So this is my favorite conference in all the world. I teach people Python morning, noon, and night. I was talking in my sleep at night. I asked my wife what I was talking about, and she said, "You were teaching Python." So I can literally teach it in my sleep. So my mission is to train thousands of Python programmers. I am almost up to 10,000 people that I've trained personally. If you need to get in contact with me, here's how you do it. I also teach Python through Twitter. I don't tweet about fun things. I tweet about Python things. So if you'd like to keep learning Python from me, just follow me at Raymond H. And let's get going. All right. The type size is suitably tiny. I will make it large. All right. So I'll start out with significance. I believe that testing is the heart and soul of software engineering. Programming is where we tell the computer what to do, and testing is making sure we told it the right things. But I like to think of it a little bit differently. Testing involves deciding what is the computer supposed to be doing. And when you view it in that light, it's actually more important than the programming itself. That's where the thinking step comes up. Like, what is it that we're trying to do? So I believe that the how should I do something, the programming is less important than the what should it be doing. So that's why I believe testing is super important. Several of you are beginners. Raised your hands earlier. This is for you. The basics of unit testing. The unit test module is huge. Py.test is now this huge. They are very, very big. You should not be worried. You only need to know 3 assertions to get by. Assert equal takes the output of a function and compares it equal to a test value. That 2 to the 5th power is 32. Assert true checks to make sure that we get a true result. Is this password consisting only of digits? And assert raises test for an error, a special kind of error. It's not a value error, it's a vuawe error. Okay, it's a typo. This tests for a value error, and you need to know exactly 3 things in order to unit test. If you would like to do something a little bit more advanced and run your test in a loop, there's one thing you need to know. It's the concept of a subtest. Subtests are kind of interesting. All they do is inform the error messages. They give more detail in the output. So anytime you have test in a loop, who's your new best friend? Subtest. That's exactly the case. And you write down in here every parameter that you want printed out in the output. If you don't do this, your test will test for you, but when they fail, they'll just say, something went wrong, and I won't tell you what it is, which will make it remarkably difficult to fix. And the last skill Everything you need to know about testing is here, which is how to organize your test. We organize them by classes. With PyTest, you can start out without classes, but if you want to test at scale, you organize by classes. So here I've put together some sequence tests. This is modeled right after what's in the Python standard library. We have a whole set of sequence tests that test any kind of sequence. But then when we get specific, like testing a list, we subclass some sequence tests, and we add on some extras. So here are some things beyond the basic sequence test. Here's some additional things that we do for list. Likewise, for tuple, it repeats all of the sequence tests, and it adds 2 additional tests for that are specific to tuples. In this way, you can organize your test and not write the same test over and over again. Sir, should you write the same test over and over again, or should you use classes? Excellent choice. That is what I would do as well. All right, the shout-outs. The things that this talk is not about, but if you're in the testing business, you have some friends. Which do I like better? Python's wimpy unit test module or the awesome py.test library? PyTest. It is vastly superior. If you have a choice, you should use that. Why do you think I write mostly in unit test? Because I don't have a choice. That's what the standard library does, and we test the library on itself. A lot of you raised your hands for coverage. Coverage lets you know what your test cases have covered, and more importantly, what it hasn't covered. If you aren't using coverage now, the on-ramping for it is very simple. You can learn to use it in about 5 minutes, maybe less. So don't be daunted about learning another Python tool. Sometimes you want to learn a new tool. Oh, I'll just learn a little bit of Django, and a couple months go by and you know a little bit of Django. But coverage is different. 5 minutes goes by and you pretty much got it. But I'd like to pass in a note of caution. It is very common when people start using coverage to look at the percentage of coverage and start trying to grow that number as if having the number is bigger. Is it possible to have bugs in your code and still have 100% test coverage? Is it probable? Yes, in fact, it's the case. The 100% means nothing. And to get to 100%, you have to test a lot of things that rarely could happen, possibly will never happen, like being out of memory, which is quite difficult to simulate. And one of the things that will happen if you try to make the number just bigger is generally it's a waste of time. There are lots of ways to improve code quality. You could have spent some of that extra time doing code reviews or improving your documentation or user testing. So I love coverage, just don't get in the business of trying to make the percentage bigger. The percentage is not a measure of quality. And a few of you use hypothesis. This should also be a new best friend. This is not a 5-minute learning curve. This is a greater investment of time on the order of several hours. But even if you only learn hypothesis and never use it, you're better off. It will teach you the core concept of thinking in terms of specifications, invariants, and contracts. This tool is also one that I want to give you a caution on. It is a means to an end. It is a way of doing testing, but it is not a goal in and of itself. I have seen plenty of people learn hypothesis, and then their new mission in life is not to test software, it's to go use hypothesis somewhere. And you can achieve your goal of using hypothesis everywhere. But that's not really our goal. Our goal is to write correct software. So don't let that one sucker you in. I left one off here that is another bit of a sucker play. How many of you use the mock library? How many of you spent lots of time mocking objects and it was more fun than writing the code you were supposed to test? It's very seductive. I've seen entire teams get seduced into, what were your accomplishments this week? We wrote a lot of mocks. Did you write tests? No, we wrote the mocks. The mocking was more fun than the testing, which was more important than the code itself, which is the part that actually adds customer value. So don't get lost in a sea of mocks. Mocks are really useful sometimes, but you can see I'm really opinionated on this subject, so this is my chance to give you my opinion. I think they are very useful at times, but they can sucker you in and eat enormous amounts of time. Also, what's that? They are in fact fun. I agree. Okay. Mocks also have a bit of an issue with them is that you're teaching the computer to lie to you. You program the computer to say, Raymond, everything is okay. Then you write another mock to say, Raymond, molto bene. Later, I make a mistake. What have I programmed the computer to say? Molto bene. Okay, everything's good. Keep going. And so you've taught the computer to lie to you. That's why they are fun. In fact, that's the case. So these are a couple side trips you can go on the way to testing. I mentioned coverage has 5 minutes of on-ramping time. PyFlakes has seconds of on-ramping time. It is the most efficient tool you can use to find bugs. There are linting tools that present enormous amounts of data. Only a little bit of it is actionable. Also, it gives you a rating on your code. Your code quality is a 2.7. That was a number I saw when I ran it on some code written by Guido, which by definition is perfect code. Okay, so I don't really trust the linter's rating, but PyFlakes is wonderful. Almost everything it tells you is actionable and important. It is an easy-to-use tool. I would make these 4 your new best friends if you're going to be in the testing business. All right. What we came here to talk about is writing tests. And a predicate is any function that returns true or false. And in the testing business, that's what we really want. Go or no go. Are things good or are they not good? What will the mock tell you? It's great. It's all just fine. Okay. So what we want is predicates that express the assertion clearly and plainly as possible. That's really easy to do for the test you see in the documentation. Assert that the cube of 10 is 1,000. That is clear. That is beautiful. That's what it's supposed to be. But for more complex tests, I'd like to teach you how to write those. Ideally, I don't want your test to be a big blob of you write a whole bunch of code that is as complex as the thing you're trying to test. And at that point, you doubt, is my test correct? Or is the code correct? Or are they both wrong? What you want is a test that gets right to the heart of the matter, that says, here's what I'm testing. And there is an art to doing it. And the art isn't in using the testing tool. The art is in using the core Python. So in fact, I snuck in a testing talk, a talk about the core Python language. So let me go over with you the tools that we need for elegant tests. One is for Boolean operations. Whenever you have a chain of elifs, you can often replace it with an and. We say that these are short-circuiting, which means that if the first test fails, then the second one will never happen in the first place. Which is easier to read? The big pile of nested ifs or the short and? Short and, there you go. All of this looks obvious until we get to, you know there's going to be a test on this, right? Oh, there is. You think I'm kidding. I am not. I've got some tests that have been written that we want to all go improve together, and the answers I'm giving to you right now. So make sure you take all of this in. And the same is true of ors as well. Now, what if you have a chain of ands and r's? We have 2 friends, Annie and all. Whenever you have an A and B and C and D, if you see a big pile of ands, what can you replace it with? All. If you have a big pile of ors, what can you replace it with? Any. And it says more clearly, in straightforward language, are any of these things true? These are some of your best friends in writing test predicates. Another best friend is set operations. Now, of course, I'm biased in all of this. A lot of these things are things that I've written myself. I was the person who wrote sets, and I wrote any and all. But I wrote these things because I do a lot of tests, and I needed these things, and I thought that you would need them too. So I am a little bit biased in my presentation, but I think you'll see by the end that we can improve your code quality quite a bit. By the way, are you enjoying yourselves? Yeah. How's my pace? Too fast, too slow, just right? Fair enough. Okay, so set operations. The number one thing that sets are good at is checking whether some element is a member of a set. It does that very quickly, and it does it in plain language. Union combines sets. Intersection finds elements that are in both. Difference gives you the complement. Subset says everything is in the first set is in the second. And I bet you probably knew all of these except for this one. This one is a mathematical term. I had some consternation in naming this. From set theory, the word is actually called is disjoint. That is the mathematically correct word. But to be more plain, I could have called this method non-overlapping. I want to make sure that two things don't overlap. I have a main plan for touring Florence, and nothing could possibly go wrong. Should I also have a backup plan? No. Of course I should have a backup plan. No. Things go wrong. Trains don't go where they're supposed to. The traghetti yesterday was not where it was supposed to be. I went there was no traghetti. You walk all around the various bridges. You go through the giant maze that is Venice, and finally you end up back at your hotel. I needed a backup plan. Now, you've got a main plan and a backup plan. Should they be the same plan? No. What Python word would allow you to express that in a single word? I'm pointing at the answer. Is disjoint. Main is disjoint failover plan. So, except for is disjoint, you might not know this, that all of these operations, the set operations that you've known since you were children, also apply to counters as well. Counters implement what are called multi-sets. A multi-set is just like a regular set, except it has a multiplicity. So this is a set of the red and greens, except we store additional information. There are 2 reds and 1 green that we need. Now, what do we have available? 3 reds, 4 blues, 1 green, and 1 black. And the question is the sufficiency problem. Do we have enough colors available to satisfy the ones that we need? That can be written in one short, beautiful line of Python. Are the colors needed a subset of colors available? Who learned something new? Oh, fantastic. List comprehensions. When you see code like this that starts with an empty list, loops over something, computes a value, and builds it up, who's your new best friend? List comprehension. So that same code can be written this way. Shorter isn't always better in a number of languages. Sometimes if code is shorter, it's harder to read. But in Python, particularly for list comprehensions, you can learn to read list comprehensions more easily than this code. This has easier individual steps. But in fact, this thing is not an individual step. It is an aggregate step. We think of it as one thing. I read it left to right. Make me a list of the squares of x, where x comes from this range. That's a single sentence, a sentence being defined as a complete thought. In other words, you can think more clearly with code like this than like this. However, if you need the data right away and you're going to consume it just once, who's your new best friend now? Who created generator expressions? Oh, that was me. I'm the generator expression guy. And you take these square brackets off, and you now have a memory-efficient version of that list comprehension, which might be important to you if you're looping over a much, much larger range. And so this reads very nicely. The sum of the squares of x, where x comes from a range. We'll use a lot of those. There's a lot of functional programming tools in Python, but the one I want to call out right now is map. Map fell out of favor once list comprehensions landed. How many of you don't use map anymore? How many of you should start using map again? Oh, it's all the same people. That's exactly the case. There's several reasons to like map. If you already have a predicate made, code is clearer with map than it is with a list comprehension. It's also faster, but more importantly, besides the built-in map, we have other maps. We have one in the multiprocessing module. So if you can get code to run with map, with just a one-line code change, you can turn that into a multiprocessing map and run all of your tests in parallel. Ooh, cool. Can you do that with list comprehensions? Oh, no, you cannot. Reducers, do you think they make things bigger, or do you think they make things smaller? Smaller. A lot of data goes into sum, only one number goes out. Lots of data goes into minimum, only one number comes out. All of these are reducers. This says, give me the first element of the data. This is the last. These are all obviously named functions, except for this one. So mode is often forgotten. It's buried in the statistics module, and the statistics module is all about what? Statistics. That's not surprising, except that buried in there is mode, something that we need for a lot of other things besides statistics. And so it's good for finding a dominant value, something that comes up in testing a lot, and it takes a testing concept and reduces it to one word. What is the most of something? are most of the ports as their status up, as most of the ports their status down. So you can think of it as a vote counter. It counts all of the votes and it tells you who won. In this case, you want to know, are there more trues or more falses? What are there more of? False. Okay? So mode is actually a really helpful tool. All right. I get to show off a bunch of things I wrote. Guess who wrote all of the iter-tools? That's me. I'm the iter-tool guy. I remember at earlier conferences, we used to go around introducing to each other by, it was often people who wrote packages or core developers, so we introduced ourselves to each other by what we wrote. Py.test, iter-tools, iter-tools, Py.test. Nice to meet you. All right, so I was the iter-tools guy. So one of the ones that you're going to want for testing is Cartesian products. And they're really useful for generating all possible test parameters for a function. So take the Python open function. Open takes a file name, it takes a mode, and it takes an encoding. You want to do thorough testing. Should you test one of those cases, or should you test them all? Test them all. Are they fun to type out by hand? Oh no, they are not. Who's your new best friend? Product. I want the product of the file names with the modes and the encodings. So here's the first file with the first mode and the first encoding. You can loop over these and cover all of the cases. So you might not use combinatorics elsewhere in your life, but what they were really for, where they really shine, is they come up a lot in testing, doing high volumes of test. Permutations, what they're useful for is exploring orders of user action. So you've given the user some buttons. Will the users press them in order, or will they press them almost randomly? Users like to press buttons. I wonder what this one does. Even though you've got a big message. Never press this button before you press that. What will they do? Wrong order. So you take all of the actions. Press play. You can press stop, press eject, and press rewind. Let's run the permutations of those and find all possible user orderings. This is a remarkably good way to find bugs in user interfaces where if somebody does something a little bit out of order, if I press the buttons in this order, I don't have to log in anymore and I have full access. You are going to test for that, right? If you don't, will somebody else test it for you? Oh yes, there are scripts out that do almost exactly this with published APIs, and they go out and just try all of the key sequences and orders, and then they look for security holes, and do they exploit it or do they sell it? They sell it. And then someday, when you're at your most vulnerable, somebody comes to collect. All right, and then combinations are used when order doesn't matter, when people can do a grab bag of things. I want some of this, some of that. I'll skip this, I'll take some of that. And so in this case, a grab bag of colors, what are all combinations of the colors taken 3 at a time? Can you see how these things would all be useful for generating test cases? All right, fair enough. How am I doing on time? Okay, good. All right, power set, that's a recipe in the iter-tools docs. Power sets get large very quickly. They go up to 2 to the power of the number of inputs. So this would be 2 to the 4th power, 16 inputs. So don't give it 1,000 inputs. It will never finish. So be careful with your power set function. What is it useful for? Generating all possible subgroupings. Okay. So in this case, I want to find out what happens when I get each group of users together. What if Adam is alone in the pandemic? What's happened? What if Adam and Beth are alone together in the pandemic? What if Adam and Beth and Cindy and Dave are all in the same place in the pandemic? Will they still be friends afterwards? You want to test all of these cases. Some combinations will work better than others. Okay, something new you might not have seen before unless you've been following me on Twitter. The capture recipe. The capture recipe runs a function, and it returns the value of the function and none. Not very exciting. But if there's an exception, it returns the none on the right side and the type on the left. So what this does is take you out of the exception world back into the data world. Some of you will recognize this from programming languages like Go, where it is the norm instead of passing exceptions around. I am not giving it to you for that purpose. I'm here giving it to you for a higher purpose. What is a higher purpose than programming? Testing. That's what it's for. And here's how we use it. I use it a lot as a Python core developer. We developed in the math module something that computes the number of combinations. And there's fairly simple math formulas for that. There's also hard math formulas for that. Maybe what we should do is implement it in the test suite in the simplest way and implement it in the math module in the fastest possible way, and then compare them and see if they're the same. And so here's an example of how I would do that with the log function. Let's say we had a regular log, and we had some alternate implementation of log. What I'll do here is loop over many possible inputs. What happens if I give it an infinity, a nan, a hello, a 0, a -1, etc.? Some of these things will raise exceptions. Some of them will return special values. What this does is it runs the function with the value, but if the function returns the exception, it just says, do the same two functions, return the same exception. Do they both give a value error? Do they both have an overflow error? And this is the way you match them up. So as a core developer, I use something like this quite a bit. Without this little tool, this code is obnoxiously difficult. What do we prefer, simple or obnoxiously difficult? Yeah, excellent. All right, are you ready for the test? All right, here's the test, applying our knowledge. So I've got some sample test data that we have collected that we want to run tests on. We've loaded a device status. We've got a user setting for load limits. We have the total load on the system at 75%. We have a set of ports on a router that are dead ports. We have a set of ports that are currently in use. And we have a company policy of the ports that are allowed to be in use. We also have a test function to take a port number and determine whether it is an active one. Probably should have changed the doc string on this. In this case, it does something simple like compute whether it's an even number. But normally, testing if a port is active is you go and query the port and say, are you currently active? So you have to imagine a more interesting function there. This is our starting point. So these are tests, typical of ones. I teach a lot of Python, but I also do a lot of code review for companies. And so I go into companies big and small, look at their code, and every single atrocity you see here was committed somewhere by someone in production code. All right, and these I say atrocities. Some of this is not terrible. So here are the things that a person is trying to do, and they've written a set of assertions as in py.test. I've saved for you, and when I give you the slides, here's the problem. You can work through it later, and the solution. I'm going to foolishly try and do some of this live. Wish me luck. My plan was to do a live demo, and then they served wine at lunch. Nothing could possibly go wrong. Is that big enough for you to see? Can you make it out? Was that a no, you can't see it, or bigger? The man wants bigger. Okay. Bigger you shall have. Bigness I shall do. All right, there we go. We're trying to categorize the load level into light or heavy. This is not difficult. If it's bigger than 70, it's heavy. Otherwise, it's light. However, this reads like a series of steps. Do this, do that, do the other. In our test, we don't want them to read that way. We want to say, what is it we're trying to do, heavy or light? So your tool that you want to use here is called the Ternary Operator. Sometimes called a conditional expression, which has a very interesting history. Do you all know the history of this one? Everybody wanted a ternary operator. Who didn't give it to them? Guido. We all bugged him and said, give us a ternary operator. He got tired of being asked. He figured out a way to get rid of us. Here was his plan. He said, I'll give you a ternary operator if you can all agree on a syntax. What had never happened in the Python community ever before? Agreeing on a syntax. Guess what happened for the first time? We had giant discussions. We had votes and debated all kinds of syntax. It went on for months. And in the end, the community presented to Guido, we all agree, here's the syntax. You promised us a ternary operator. How many of you know the punchline to the story? He said you can have a ternary operator, but not the one you voted for. This is a true story. All right, so in this case, it is the category is heavy, but only if the load is greater than 70. Otherwise, it is light. It reads very naturally as a sentence. It's going to be heavy if the load's over 70. Otherwise, we consider it light. If you can express it in a single sentence, it probably belongs in a single line in Python. All right, next one up. You all can help me with these, though. We're trying to categorize. The next one is handling the load limits over 50 when the limits are off. Any suggestions for me? Whenever you see a series of truths and false like this, an if-elif chain, you should immediately think of our Boolean replacements, the ands and rs. In this case, an answer would be the short circuit R. Okay, and we go ahead and do an assert. The load limits I was going to just press run every time to make sure that all these tests still pass. I'm feeling fear now. We'll see how it goes. Live demos. Oh, the tests all still pass. Okay. I hope you can see that this code is much more difficult to reason about. It's actually easy to put something like this in test and be testing the wrong thing and not know it. This, on the other hand, is clearer than a comment describing what we are doing. In fact, in a number of these cases, the code will be shorter and clearer than the related comments. Okay, you've seen the last one, so you can probably make a guess of this one. And one other thing, and chained comparisons. So when you have an and connecting two comparisons, often we can put them together in a chain comparison. So in this case, I'll start with making sure that it's an integer first. We're making sure something is a percentage. And I don't have to do two ands. I can take the put in the range. A percentage doesn't get lower than 0 and doesn't get greater than 100. Unlike what your coaches will tell you. I want 110%. I want you to take some math. Okay, here we go. All right, do you agree that this is better than this? Okay, not a lot better, but a little better. Okay, what about this one? Who remembers chains of ors? What should I do? Any would in fact be an improvement. What would be even better? Oh, don't forget sets. Sets are one of your best friends when it comes to testing. I'd like you to get good at this thing. I'm going to give you these slides because these are things I've all found in real code. And you can clarify, hey, it is one of these numbers. Sets express lots of test predicates very simply and clearly. All right, am I doing on time? Not as good as I'd like. Okay, what about this one? Our device status. We want to make sure the device is connected before we run any test on it. Does this seem like a reasonable test to you? Does that seem like a reasonable test? What's wrong with it? There you go. That's exactly it. The test would still pass if we did this. The in operator on strings does subset test. This would still match. Are any of you high-frequency traders? You write a program to read the earnings report within milliseconds of it being published. You write a test. If big profit in earnings report, buy. This is great until the earnings report says we were expecting a big profit, but we lost it all. Okay, and you will go the wrong direction. By the way, does this happen to real traders? Oh yes. Every time Tesla announces a new product, the market price shoots way up, including on April 1st. What happens on April 1st? April Fool's Day. There was a tweet from the official Tesla account. for a product announcement for a new Tesla self-driving watch that had a battery life of 2 years. Every human being who looked at it said, "My, that's really funny." Every program that looked at it bought a lot of stock. Over $300 million was lost in about 5 minutes. That's a true story. Okay, so what do we want to do about this? There's actually several ways to fix this. The easiest way is this. If you split it into fields, the list comparison will test whole words rather than portions of words. It is much safer to do an in on a list or a set than it is on a string. Everybody understand why? Okay, you're not going to make this mistake. Okay, fair enough. All right, now for the really fun ones. Ooh, there's flags in loops with trues and falses. Those are almost always bad. What can we do to make it better? Whenever you see a list like this, what kind of comprehension is suggested? Yeah, so we can immediately make an improvement by finding out whether the port are in the dead ports for every port that is in use. And that will build up a list of these. Now we want to check these conditions, which we can do with which one word summarizes trues and falses. Yeah, in this case, it'd be an assert, not any. Okay. All right, so a list comprehension now makes this more comprehensible. Do you agree that this is easier to read than what we had before? That said, I'm consuming, I made a list and then I ate it right away. What would be better? Oh, you all are learning so well. You're making me proud. All you do is get rid of the square brackets, and now you have a generator expression. And so you have a memory efficient version of that. Do you agree that it's getting better? What could I do to make it even better? Sets. Oh, you're doing good. So one of the things that we could do is find the intersection between these. We'll take, are the dead ports, their intersection with the ports in use. Okay, and then we want to make sure that there is no intersection between them, so the opposite of the Boolean value there. This code will be faster. There's no variables along the way to mess up, no comprehensions to make. This code is memory efficient and fast and clean. Do you agree it's better? Can I improve it more? There you go. I'm impressed. Okay, I want to know if the dead ports, is it disjoint with the ports in use? I'd like you to look at the magnitude of the improvement between what we started with and down here. This is using Python built-in tools to great advantage. Are you enjoying these exercises? Cool. Do you feel stronger? All right. Okay, let's see how you do on this one. Any suggestion? We've got flags again. Anytime you have flags in a loop, they're almost always bad. Well, the first direction that we went in, I've actually gone to the third example. I'll go back to the second one here in a moment. So we want to make sure all the ports in use are under 1024 so that we leave the higher number of ports available for user use. When you see the loops, what is the first idea that should come to mind almost every time? List comprehension. That is exactly the case. So we could, once again, make a list of is the port in use for each of the, is it already, that reads more nicely. I want a list of the ports over 1024 for every port that is currently in use. The Booleans, false and true, are equal to what two integers? 0 and 1. Can you add up integers? Yes. Can you add up Booleans? In fact, you can. And what we'd like, in this case, is for that sum to be equal to the total number of ports in use. Okay, and actually I'm going to do a less than here. Get that direction set. Okay, so we can add all those up. This is code we used to write until we got a new friend that did this for us and did it more efficiently with an early out. Who's our new friend? Starts with an A, has 3 letters. All. Okay, so you can use any and all for these as well. So this would become much more compact. Instead of adding up all of the Booleans, which used to be a very common practice, and you'll still see it in some Python books. Just move this one down, keep the parens so that the world doesn't fall apart on me. Bam. All right. I made a list and I consumed it right away. What can I do to make it better? There you go. Generator expressions. Immediately makes them more friendly. However, I've been teaching you one of your other best friends is who? Okay. But all right, and let me check it. So I keep my thoughts together here. We will go ahead for this one, and that's the actually, yeah, I'm going to leave that one as is. Okay, let's, because I'm tight on time, for some of these, I'll stop with the, instead of doing the generator expression portion of it, the even numbered, that actually should have been changed to is in active use. And we had a predicate for it, is active. And the interesting thing is we're applying a function over and over again. What tool is really good at applying a function over and over again? Map. There you go. So we can map the question, is active, to all of the ports in use instead of counting them. That gives you a bunch of trues and falses, and then we could just wrap and assert any around it. So whenever you need to reduce a bunch of Booleans, think about ands and rs, think about any and all. When you need to apply a function over and over again, think of map. Do you agree that this is shorter, more beautiful, and easier to get right than the code above it? Yeah, I think so. And more interestingly, it is shorter than when we say the comment that we would use to explain it along the way. All right. And my favorite is the last one. Because I have other places I want to go, I will go directly to, this one has a nice set solution. I would like you to reach for sets whenever you can. Are the ports in use a subset of the allowed ports? Have I successfully communicated the idea that using sets and counters and any and all and map and all the tools that I had just given you lead to very clean looking test predicates? Fantastic. I've achieved my goal. You all are smarter now. You will all go write great tests and the world will be safer. And when I fly home on the airplane, it is less likely to crash. All right. By the way, I'm giving you these slides, so I'm giving you the challenge at the top. And I'm giving you all of the suggested improvements at the bottom. Okay, and wow, something terrible just happened with my slides. A whole section disappeared. All right, we do it from memory. How much time do I have left? I like the way you're thinking. All right. I've got a number of newbies. I'd like to demonstrate test-driven. What's the time? 10 minutes. Okay. Little test-driven development. I have a fully worked out exercise here where I'm going to take a simple tool and take it very far, and I'm going to mirror the kind of tests that we do throughout the standard library. And we're going to develop some code that computes a triple value and computes a square. the first thing you do in test-driven development is A, write the test, or B, write the code. What do you do first? There you go. All right, hold on. Let me just create a new file. You try and arrange your windows beforehand. Hopefully your main plan and your backup plan are not the same plan. Save as, and this will be math tools live.py. In case you're wondering, for my personal, when I teach, I always use idle or Jupyter notebooks, but for my personal coding, I always use Emacs. People ask me about that all the time. Different users have different preferences. PyCharm is also fantastic. All right, so I run my test. We've tested triple. What did I want to communicate to you and how to write test here? We have one common everyday case. These two things are corner cases. 1 and 0 is input, and then we have an error case. And when you test the basic functionality of something, you usually do this first. All of this will be on the slides that I will distribute shortly after I repair them. Something went hideously wrong. That said, I used version control when I made my slides. It will all restore. I'm confident. My main plan and backup plan are not the same plan. What we, all right. Did this save in the same directory? Okay. The man says, never talk and type at the same time. Thank you. All right. What we love about test-driven development is it teaches you as you go along. The important thinking part has already been done by the time you write the test. The getting the code to actually do it is usually the easiest part. So at this point, I can't import square and triple. They're undefined. What do I need to do? Define them. Square of x, return a value times itself twice. Okay. And triple. Not exciting functions, but we're here to focus on the testing rather than the functions themselves. Return a value plus itself 3 times. Okay. The idea here is we're doing the simplest possible thing to get the test to pass. Okay, and here we go. Let our test suite teach us about the errors as we go along. I'm actually going to comment out the square for a moment so that I get smaller number of errors. And I'm now at the point where it says I'm supposed to return 15. A legitimate technique is to do this. It's supposed to return 15, and now it does. Okay? This is stubbing out the function. That said, it goes on to the next case and fails out. It is actually common to stub out a bunch of functions, get the whole system integrated, and then go back and fill out the details. Who is old enough to remember what that's called? Top-down structured programming. Okay? You start with the biggest view of the world, you stub out the pieces, and then gradually fill out the details as you go along. Successive refinement. So now I need to consider how to triple numbers. To get to 15, I could do that. For this one, I could do that. I see a pattern here. Maybe go research it on the internet and come up with this idea. The total starts out as 0, and I'll loop 3 times because we're adding it together 3 times. This is not going to be a great version of triple. And return total. And see how it does. If you all work through the entire exercise on the slides, there's a number of interesting tricks in there. The C code will fail immediately because we'll use an unsigned short and we'll have a range overflow error. We'll show how to test the Python code and the C code at the same time by using classes to organize the code. And there will be a very interesting failure in triple when you try and simplify it a little bit later to 3 times x. Okay, so we now have a passing test. We can go on to the next case, and we can take advantage of what we had learned so far. You know, I've got a pattern for how to add things up. The square of 3 is that, the square of 4 is this, and the square of 5 is this. Do you see a pattern? It wasn't intended to be a hard problem. Do you see a pattern? Okay. It turns out it's exactly the same code, except we just vary the number of loops. This is not excellent code. All right. What's range 4? Now, hold on here. All right. Square of 25 returned none. How did I get a return none? I didn't save. Not a 4. Okay. You see a little star up there? There you go. We have 2 passing tests. At this point, you check into version control, say, I've got something that's tested, and ship it. Nothing could possibly go wrong. Bug report. First bug comes in, and a person says, I tried to compute the square of -5. What should that be? What is it? 0. Wrong answer. So the pattern is build a new test case for it, and this is important. Make sure it fails to reproduce the test case, then go make it succeed. So put in the bug number. I should probably stop at some point to give some questions. Okay, good enough. All right. And we'll put in this same test case, handle the negative numbers, typically a negative support. We watch it fail, then go make it succeed. And they have a long series of steps to finally get us to the code that you expect on this sort of thing, but with the idea of modeling what happens in real software development. If x is less than 0, just multiply it by -1. We can put in some all kinds of optimizations later, but that fixes that bug. Some of the other ones that you're going to see is at some point it is going to fail with this one. Square root of 6.25 should be 2.5, or the other way around, 2.5 should go. But this currently doesn't have float supports. At some point, we will simplify this to return x squared and make sure that that matches another bug. Which would be the 2.5 and 6.25. See if we can get that test case to pass. Is there an obvious improvement to the code at the top, given what we did at the bottom? What's the easiest way to triple a number? Fastest way? Multiply by 3. Simple, easy, beautiful. Nothing could possibly go wrong. Your test will save your bacon. In this case, we've got a problem. Triple hello is not raising an error. It saved us from taking code that was correct and in the process of optimizing it, breaking it. If I convinced you that tests are awesome and that you need them, you're all supposed to say yes. Okay. Okay. We'll raise a type error. There's other things I should do to beautify this code, but I wanted to walk you through the process of development. Some of you are brand new. Software isn't born correct. It grows to be correct over time. We can specify it early on. We get back bug reports. We iterate. We optimize. When you all get the slides for this, you'll see I take this quite far, build a C code for it, find the flaws in the C code, have extra features in the Python code that is not in the C code. All of these things happen in the standard library. Did you all learn something new? Yes. Fini, questions?
Hello? Okay. Thank you very much.
Okay.
So yeah, we have a bunch of questions on Slido, so I'm going to read them. So the first question is, for larger teams, would you recommend using pre-commit hooks and pipeline checks? Or for methods such as Black or a mix of the above?
Okay.
Pre-commit hooks and pipeline checks.
The question is, do I recommend using pre-commit hooks? Every major project I know of uses some type of pre-commit hooks, so I can't say no to that. On the other hand, I was a high-frequency trader at some point, and sometimes you have to fix things. And when you tell the computer, I want you to run this code, and it says no, that is not a good relationship. Oh, I don't like your spacing here. You didn't put a comma there. There is a little bit of Unicode, and you put someone's Italian name in code that was supposed to be. Run the code. So in a world with pre-commit hooks, I like some way to disable them or bypass them. I have a problem as a core developer where periodically I review other people's patches commonly, and a whole bunch of commit hooks run all of our tests. But sometimes, for various reasons, those tests die. And what happens is, I can't push this person's obviously correct fix. They found a bug, they're fixing it, I've approved it, I say go, it's going to fix everything, and the CI engine is borked up. And currently we have no auto restart button, and I have to resort to things like completely closing the bug, reopening it, and trying to convince the CI that it is here. So make sure the computer remains your friend. But yes, people use CI hooks all the time. Next.
Some of your examples claim to make the test easier to comprehend, but at the same time assume quite a bit of knowledge about the core language features, such as is this joint. How does it make it easier to understand?
Which part did they find difficult to understand?
I guess set theory and things like is this joint.
So the question is, how does using set theory make code easier to read, given that some people might know it? I train people for a living. People not knowing things is a solvable problem. You don't know things, you call me. An hour later, you know your set theory, your any and all, and that sort of thing. So we can teach you it. Avoiding the core language is possibly the worst thing you can do. I get questions all the time from people who come from another language. How can I do this and avoid using a Python dictionary? I'm like, why would you avoid the easiest to use, fastest, cleanest solutions? Like, well, that's not what I do in the other language. Like, I can teach you in 5 minutes how to use a dictionary. It's your new best friend. So don't avoid the tools. And set theory in particular sounds difficult because we use the word theory. But we teach sets to, my son encountered sets in school when he was 8 years old. You can learn, everybody gets the problem, the intersection of even and primes, the primes that aren't even, evens that aren't prime, union, intersection, and difference between those can be learned with a Venn diagram in about 5 minutes. It is not a deep skill, but I believe the code was easier to read because we reduced it from about 50 words or 30 words to about 3 words. That code's unequivocal, fast, beautiful, and easy to see what it gets right. So I disagree with the premise of your question. I think sets are easy to learn and are clear. Do the rest of you agree with me? Yeah, fantastic. And if you have a learning problem, I can solve that, especially the core language. Never avoid the core language. The built-ins are there for a reason. Next.
I think we have time for 1 or maybe 2 questions. So what was the original syntax proposed for the ternary operator?
I have bad memories and have blocked it out of my mind, but I did write a PEP for it, summarized all of the results. So you can search for PEP and ternary operator and see I conducted an election. Somebody decided that they wanted the election done differently, so we had a second simultaneous illegitimate election with almost the same results, but I think it was the question colon from C might have been either at the top of the list or the second best. The argument there being that same syntax is used in so many different languages that when people come to Python, they would tend to already know it. Guido liked the if and else because we didn't have to introduce any new keywords. Everybody already knows the words if and else. And even though it seems weird because you haven't seen it in other languages, it is actually a natural way of expressing in most languages. You're going to pass my class if you get better than a 70. Otherwise, you'll fail. I'm going to go have fun walking around Florence today if it doesn't rain. Otherwise, we'll do an indoor tour. And so it's a very natural way of speaking. And once again, Guido was correct. Okay.
So we don't have any more time for questions. Thank you again, Raymond,
right.
for your speech.